Okay, so now we're going to prove the triangle sum theorem. And this is one of the basic theorems of geometry that's used in a lot of geometry classes, but it's not always proved. And it says that if you have a triangle and you take the measure of each angles A, B, and C, and add them up, you always get 180 degrees. And that's what I've written here. In any triangle ABC, the measure of angle A plus the measure of angle B plus the measure of angle C equals 180 degrees. And people use this proof a lot. They use this theorem in order to solve problems, but it's not proved yet in this course. So that's what we're going to do today, and try to prove why this is true, and why is it that we get 180 degrees out of this. And so just to explore a little bit before we actually get into the proof itself, I have a triangle right here with 3 different angles, and what I'm going to do is put a horizontal line at the very top of this triangle with my ruler here, okay, and then I'm going to cut these 2 corners, the lower corners down here and over here. So I'm going to cut that out. Okay. And I'm going to mark these corners just so we don't get this mixed up. Now if I take these corner pieces, these angles from the other corners of the triangle, and I try to match it to the 3rd angle here, you can see that the 3 angles of my triangle form a straight line or a straight angle, and that's 180 degrees. Okay? And if you do this with every possible triangle that you can make, it'll turn out to be the same thing. You can cut out the corners, move them up here to the other angle, and together the 3 angles form a straight line or a straight angle that's 180 degrees. And that is the reason why all of the angles of a triangle always add up to 180 degrees. But this is only inductive reasoning. It's only something that we learn by patterns, and we can't prove that this is true for all triangles using this method, because we have to try it for every single triangle, and there's an infinite number of them. So in order to make prove the theorem true, we have to do this deductively using somewhat of a formal proof. Okay, but I'm going to use that same idea of having this straight line at the top. So the first thing that I'm going to do is draw a line through B that's parallel to AC. Okay, so I have this line here going through B that's parallel to AC, and let me just mark this to show that it's parallel. And let's go with our traditional statement and reason proof for this one. Okay. And the first thing that I'm going to say is draw line through B parallel to AC. Okay, and our reasoning here is that it's the parallel postulate, and you can look this up in the book if you don't remember, but the parallel postulate says that if you have a line and a point, there's a parallel line that goes through the point. Okay, let me zoom in just a little bit here so we can see the picture a little bit better. Okay, and being able to draw the parallel line is very important, because now we can look at our image, and we're gonna I'm gonna name some of these angles right here. I'm gonna call this angle 1. I'm gonna call this over here angle 2. Okay. And looking at the parallel line, you can see that angle 1 and angle C are alternate interior angles, just like angle 2 and angle A. Okay, so 1 and C are alternate interior angles, and since the lines are parallel, they have to be congruent to each other. So that's what I'm going to say in my next statement, that the measure of angle 1 is equal to the measure of angle C because of the alternate interior angles theorem. And my third statement is that angle 2 is congruent to angle A, or the measure of angle 2 equals the measure of angle A, and the same reason as above. That's what these little hash marks mean. Same reason as above. Okay, so we have basically all of the pieces here, and what we've really done with these two statements, statement 2 and statement 3, is to say that we're going to cut these little angles here and put them at the top, just like we did before, but now we have a deductive reason to say that. And the next statement that I'm going to say is I'm going to say that 1, 2, and B form 180 degrees, because you can see that they add up, all three of these angles here add up to 180 degrees. So the measure of angle 2 plus the measure of angle B plus the measure of angle 1 equals 180 degrees. And the reason here is angle addition. Now I'm taking I'm jumping a few steps in one here. To actually show this, I have to show that 2 plus B is a big angle that's a linear pair with 1. Okay, I actually have to write out a few more steps, but I'm going to write it all together in one here, just in the interest of time. Okay, so this is the angle addition postulate. And now I can take angle A and substitute it in for 2. So I can say measure of angle A plus measure of angle B plus measure of angle 1 equals 180 degrees. And this is substitution. So we almost have the statement that we're looking for here. I have A plus B plus 1 equals 180. In the last step, I'm going to take angle C and substitute in for 1. And I'm allowed to do that because 1 and C are equal to each other. So I can say measure of angle A plus measure of angle B plus measure of angle C equals 180 degrees. And this is substitution as well. Okay. And there you have it. This is the proof of the triangle sum theorem, saying that a triangle has to have 3 angles that add up to 180 degrees. Okay, and this is actually not a postulate. It's not something that's just always true. It's an actual theorem that we can prove using the steps that I have outlined here.